so let's first have a look at the next topic, which is acceleration. Okay. Acceleration as the derivative of what?
Time.
Of velocity. With
respect to time.
In other words, we don't have y's and x's, we have v's and t's, right? Everything is with t. T's are our common variable. It's the thing that, so if you differentiate, the variable always stays the same, and our variable here is time. Okay, so if we think about, we can basically just, I literally, in my notes, so if you're ever going on my notes on Edmodo, I've just taken the notes from yesterday, I copied everything, and I just changed. Everything that said displacement, I just changed to velocity. Acceleration. Velocity, and everything that was velocity, I just changed to acceleration. So, if we think about average acceleration, right? So if I gave you the acceleration, if I gave you the velocity at 10 seconds, and I gave you the velocity at 2 seconds, how could you work out the acceleration?
Average velocity.
Yeah, change in velocity over change in time, and you could get the average velocity, right? So it's the gradient, in other words. So when we write that mathematically, we have, what's it? Total change in velocity over change in time.
Equals average.
So I'm pretty sure yesterday we did the exact same thing. And then I said, how do we write this change in? How do we mathematically write change in something?
D.
We used, we used this funny squiggly, delta. Right, the D we use to differentiate already takes the limit into account. This is not the limit.
Triangle.
Huh?
Is this a
Yes, you can also use delta as the triangle. It's also used in some textbooks.
The delta of the triangle is the capital of delta.
Yeah, you can use delta as well, they mean the same thing. But the common thing to see is this little squiggly guy. This squiggly guy is not the limit. This is saying it's the change. This is the change. So you've got some x, some y value, two y values, and you're taking the difference between them. So some change in velocity over some change in time. That is average acceleration. Okay, so if I take change in velocity over change in time. But we said, what if we took values that got closer and closer and closer? So if the change gets smaller and smaller until the fact that we're literally taking two values right next to each other, right? As we reach the, what did we call it, the limit of this change in velocity over change in time, what did we get? Then we got what you guys know as dv over dt. So this dv, derivative v over dt, that is, we've taken the limit into consideration. We are now not considering a change in velocity and a change in time, we are considering the values at those points. And what do we call this? It's no longer change in velocity over change in time, it's not average acceleration for, this is now instantaneous, right now. Right. So the derivative, the gradient of velocity will give you acceleration, but you knew that already. Okay? So if we started off with displacement time, and we took the derivative of this, what did we get? Change in velocity. Do we go one step further? Do we look at the gradient of acceleration?
Well, we could.
Do you want to look at the change in acceleration?
No.
No, we don't want to do that. Okay, not yet, not yet. Okay. So in your textbook they summarize this very nicely as acceleration is represented by the gradient of the velocity time graph, so whether this is a straight line or not. If we know the velocity time function, we can differentiate it and find an acceleration function, and that acceleration, is that average acceleration?
Or at that point.
No, at that exact value, that is the acceleration, right? Instantaneous velocity. Now, something interesting, what is acceleration?
Increase in velocity.
And I'm actually not going to ask it in that sense, I'm going to ask you, is it a vector or a scalar quantity?
Vector.
Right? Acceleration is a vector quantity.
So it can be negative or positive.
It can have both negative and positive values, and they
That's
then
acceleration.
acceleration.
Accelerate.
Acceleration, something like that. Okay?
We know what it means, so it's okay.
So it's a vector quantity, just like what?
Displacement.
Displacement or velocity. And the point I want to bring up here, actually Zara's right, we can add displacement to this list. Oh my word, displacement. I would definitely fail an English test, okay?
It's fine, doctors are bad handwriting.
And
Yeah.
Honest.
That's why.
If I told you to ignore
the
direction,
yes.
what would you call velocity?
Speed.
What would you call displacement?
Distance.
Distance.
What would you call acceleration?
Going faster.
Move her faster.
Go
Moving
fast.
faster, yeah.
Speeding up.
Go
Ciao.
fast.
No.
Go fast.
There is
Vroom, vroom.
no
Ciao.
there is no magnitude.
Acceleration without magnitude. It's just
Can we
ka-chow.
create-
It's just
Ka-chow.
the
It's
thing is,
ka-chow.
because of the way acceleration works, it's difficult to give it one of these names. Because remember, acceleration, you can have an increase in acceleration, but you could be slowing down.
Isn't it just
You can be decelerate or increasing, you can be accelerating but slowing down. How could that happen?
You just accelerate in the opposite direction. Automatically.
Okay, remember, when we consider velocity, anything below the x-axis means that I'm going
Back.
in the opposite direction. So here we go. Here's a velocity time graph. What could you tell me about the gradient of this graph?
Positive.
It's positive. And because the gradient of the graph is acceleration, what can you tell me about the acceleration of this graph? It's increasing all the time. Except here, between here and here, I'm actually slowing down, I'm not accelerating.
Sure.
I want you to think about acceleration like a giant magnet. It wants to force you to go in which direction? The positive direction. It wants you to go in that direction. Okay? If you are traveling in the opposite direction, so if that's the positive direction and I'm going this way, what's the magnet trying to do?
Slow you down.
To get me to go that way. Right? That's the easiest way to understand acceleration. It wants you to go that way. And so what it means to have positive acceleration when you're going in the opposite direction is the acceleration is trying to force you to go that way. Okay, and that's why you slow down.
It's not you shall not pass, you shall not reverse.
You shall not reverse. Right? You shall go that way. Okay, so if you're ever struggling with acceleration and understanding what it is, I mean that's the easiest way to understand it. It's trying to force you to go in the positive direction. Okay, so let's consider everything that we've now talked about from yesterday and today in one thing. If I want to work out acceleration, and I have a velocity function. How can I work it out?
Force over mass.
Change in velocity over change in time. What if I had a displacement function? How could I work out acceleration? Remember, this is a stepping stone. I start with displacement and I get velocity, and then I get acceleration.
V squared V over.
So if I want
V squared x
acceleration,
over.
I can take, what did we call this thing when we did calculus? We called it not the first derivative, the second derivative. So this is d squared s over dt squared. So think about it. If I gave you displacement, if you differentiate, what do you get? You'd get velocity. And then if you differentiate it again, you'd get acceleration. So now you know how to go down the line. And guess what? In the next lesson, we're going to learn to go back up the line. Okay? So there's actually nothing new to you, except we're not calling this dy over dx anymore. We're calling them by things that we would use in real life. Okay? So displacement, velocity, and acceleration. So again, you've got your little nice red blocky there, which says acceleration is the rate of change of velocity and is the derivative of velocity with respect to time, because we have change in time at the bottom. Okay? And also acceleration is the second derivative of displacement time. So just because you want to work out acceleration if you don't have a velocity function, if you have a displacement function, you just have to differentiate twice to get there. And that's really powerful, because now you don't need to have lots of equations. You just need to have one tool in your tool belt, differentiation, and you can go and get there. Okay. So let's have a look at some examples. They're going to be silly, simple ones, just like you probably had with your homework. Let's look at 6.4. Should I leave that there, or will you remember that you can go down the line?
Let's leave it there for now.
Okay, let's see. Okay, we are given a velocity function. Okay, the velocity function is v equals, somebody in the cheap seats,
T squared minus 14.
The cheap
t
seats.
squared minus 14. Cheap seats are at the back.
What?
Oh.
No, we have the expensive seats.
Oh, I see, I see.
What?
Minus 4t, not 14, sorry. 4t. Okay, and the question says, find an expression for acceleration. Okay,
Put a nice, like, window by
Or
us.
we're just the teacher.
so
The children teacher.
what is acceleration? Acceleration is Acceleration is change in velocity over change in time.
You guys don't get the nice seats.
So if I have velocity, if I have a function for it, if I want acceleration, well, that's change in velocity over time, change in time. This thing here means differentiate. Right, so you're telling me what you're doing, differentiating your velocity time graph. So let's differentiate this guy. No, it's going to be very difficult. A is equal to 2t minus 4. Very difficult stuff. Cool. Okay. Okay, break your sweat. Okay.
Ah, my brain's heating up, you know. Gonna have to.
Oh, wait for it. Wait for it. Okay, give me the next one. The next one says we also have a velocity. So give me the function for this thing. It's v equals
5t squared minus t cubed.
t cubed. Okay, so that's a velocity function, and it tells you that this velocity function from 0 to.
T. I don't think it's equal to. It's just.
Oh, is it not equal to? Okay. So in other words, this function only exists between just after 0 seconds and just before 4 seconds. Because remember, you can have those composite functions. Because velocity is not always the same, it changes. You can be driving at constant velocity for a few seconds. Then you can accelerate, then you can decelerate, then you can stop and go. And so you can have different functions to represent different things that are happening. Okay?
Is that 5t squared?
Is it 5t squared?
Is there even a. Yes, it is. Wait, hang on.
Did I not
6.5.
did I
Yeah,
not put its
6.5
capital?
is 5t squared.
So they want us to find the acceleration when t is equal to 2. Do I have an acceleration function?
Well, you can make one.
Yeah, I can make one. Don't have one, right? If you don't have something, think about what can I do to make that. So there we go, acceleration. Just differentiate my velocity function. So let's quickly do that. Acceleration is equal to 10t minus 3t squared. And they want the acceleration when? So when t is equal to 3. 2. And now we just do, very difficult. We just substitute in 10 times 2 minus 3 times 2 squared. That's going to give me 20 minus 12. So that's 8, eh?
No?
No?
20 minus. Yeah,
Yeah, 8 meters
12 is 8.
per second
Per second.
squared.
Well, this is acceleration.
Yeah, remember we are talking
per
about
second. You said per second.
Yeah, per second.
Per second.
Per second.
per second.
But I think she was repeating herself.
She was, but
Per
she was
second.
wrong.
Per second.
Okay, here's where things can get a little bit interesting, but this shouldn't be without the bounds of your ability. Right, give me the function. They gave us a displacement function. Ooh, interesting. So,
X equals a third t cubed minus 6t squared plus 15t. No.
plus. Did I get it right?
Mm-hmm.
Okay, first thing they want us to do is sketch
Oh,
the
it
graph.
has a limit of 0, smaller than or equal to t, smaller or equal to 10.
So there we have our velocity, a displacement function, and it only exists from 0 to 10. Maybe after 10 seconds the displacement function changes. But we don't care, we're only considering this.
Between the crocodiles.
Right, what do they want us to draw?
Velocity time drop.
Do I have anything that gives me
I
velocity?
hate drawing.
No, so what do I need to do?
Make one.
Okay, how do I work out velocity? Velocity is equal to? Yeah. So you need to look at the function you're given and where you want to go, right? I have displacement. I want to work down the line to velocity. If they'd asked you to draw an acceleration function, you would have had to differentiate again. Okay? So I have to draw velocity time function, so I'm just going to find an equation for it. If I have an equation, I can draw it. So let's differentiate this guy. It's going to be t squared minus 12t plus 15. Yeah, happy with that? What is that's going to be t, this is going to be v. Unfortunately, we have to label these because this is physics based and not unfortunately
The
Maths?
minimum point of the parabola is at 15.
Okay, so what we need to consider is only a few things. Okay, we weren't asked to accurately draw this. I can already see that my intercepts are not going to be nice numbers because the only factors are 15 are 1 and 15 and 3 and 5, and none of them make 12. So we're not going to solve
never
using the
mind,
formula because that's not the point of this question. But there are some things that we can immediately get. What is my starting velocity going to be?
15.
Yeah, because if I make t equal to 0 at time 0, I'm left with 15. So, there's a point on the...
But it's gonna be a sad that goes into a happy.
Yeah, okay. So based on the equation, it's a positive, it's a happy parabola. Smiley face.
Kind of, because
So-
it starts at sad though.
No, it's going to start happy.
No, because if t is 1,
In other words, it's going to make a happy face.
Yeah.
Okay. So in other words, it must go down first and then up.
yeah.
It's a crooked smile in the book.
Yes. Okay. And that's basically all you needed to put in.
Hence, find the maximum speed of the particle.
Okay, so I don't know where these values happen yet. Right? I could I find this point out?
You have to plug in, I think t is 10.
Do I know what this point is? Do I care what it is? Probably not. I don't know these things, but that's not what the graph asked me. The reason they asked you to draw this graph is you can get an understanding of what's going on to help you in the next question. Okay? So the next question says, find the maximum speed of the particle. What did it ask you to find? The maximum
Point.
speed.
Oh.
What is this?
Velocity.
Are they the same thing?
Yes.
Yes
Without
and no.
Negative
Does
could also be
speed care if something is negative or not?
Not really.
So are you looking for the highest positive value?
No, just the minimum value.
You are looking for the greatest value, whether it be positive or negative. Right? Because remember, a negative velocity is just speed in the opposite direction. That's all it is. And they've just asked for the maximum speed. Now, based on the graph and the information that I have, I don't know where that could be. It's either here, or at t equal to 10, it could be up here somewhere.
T equal to 10 is actually still a negative number.
I don't know that yet. Okay? So I need to go and find out. I need to go and work out, is that going to give me the biggest number? That guy? Or this guy? Well, this one's pretty easy. We already know. It's 15. What's this point here? This is the
Turning point.
turning point. And how do I find the turning point on a parabola?
Complete the square.
I can either complete the square or I can... What point is this? What kind of a point is this point here?
Gradient equals 0.
A turning point, isn't it? A
Oh,
stationary point. What do we know about stationary points? The gradient is?
0.
So can't I just differentiate that and make it equal to 0? In other words, think about, this is velocity, right? The velocity is decreasing here. What can you tell, or sorry, the acceleration is
T equals 6.
decreasing here, alright? It's getting slower and slower and slower, and when it gets to this point, it actually turns around. Now, it's actually increasing acceleration in the opposite direction. And then when it gets here,
That's 6 seconds.
the acceleration is 0 again. Because it's basically, it's gone away, except the wall pulled it. And it's told to go that way. Okay? So let's differentiate this. What will we get? A is equal to
2t minus 12.
2t minus 12.
Is equal to 0, t equals 6.
That acceleration is 0 there. So t is equal to 6. Except t is not speed, so that doesn't help me. But what can I do? I've got the time when that thing
You just
turns
want to
around.
do the velocity thing.
So I can plug it into my velocity equation and it'll tell me what the velocity is. So what does it give us, Fiona?
36 minus 73 plus 15.
It gives us 6 minus 72 plus 15 is minus 21.
Wait, hang on, but it's...
Yeah, it is minus 21.
Minus 21 meters per second. Okay, that's the velocity at that point. Okay, right. The next one we need to consider is t equal to 10 because we don't know what the velocity is there yet. So if I plug t into my velocity equation, what do I get?
Minus 5.
It actually ends up being minus 5
Yeah.
meters per second. So t equal to 10 happens to be there. I didn't know that from my initial graph because I couldn't care what it looked like. But now I know that at 10 seconds my velocity is minus 5 meters per second. Now considering speed doesn't discriminate, it doesn't care if something is negative or positive, which number is the biggest?
Negative 21.
21. So what's the maximum speed?
21.
Okay, maximum speed equals 21 meters per second. Okay, so we need to always remember that when we're talking between speed and velocity. Think about driving between two different towns. If I say driving to Swakopmund is positive, because driving to Swakopmund is always better, and driving to Walfish Bay is negative, whether I drive 60 kilometers that way or 60 kilometers that way, I'm going the same speed, but in terms of velocity, I'm going in opposite directions. So velocity, all the difference between the minus and the plus is direction. Right? I cannot stress that enough.
Don't hate on Walters, we have the salt